give you guys an example of a problem that will become frequent for us at times in our book or on quizzes and tests. It's a pretty routine problem, but we all need to know how to solve it. We all need to know how to explain our situation or the solution rather well, and include all the detail necessary to receive maximum credit on a question like this. Question is, as stated up here, it's number 51 in section 3.2. It was not one of the assigned problems from section 3.2, but you're not limited to doing only the assigned problems. You can do more to get the practice that you need. So this is one that we did not do together or was not required to do, but it is the type of problem that you need to know how to solve. So the question says, on what interval is the function f of x equal to x cubed times e to the x increasing? Alright. So as I try to advocate all the time when solving a problem, what you want to do first is indicate or ascertain what needs to happen. What's the concept involved in solving the problem before you actually start to do any of the actual computational mathematics. We're looking for when f of x is increasing, and from what we've studied in this course already, we should know that f is increasing when f prime is greater than 0. Okay, so f prime is greater than 0. That's when we're going to get our indication that f is increasing. Now, once we have the concept down, which again is where we should begin, we need to then go ahead and start doing the computation. The concept is sound that we need, and so let's go ahead and start working the mathematics. Okay, so I need to know the derivative. I need to know specifically when the derivative is positive, so we need to find f prime. So, to find f prime, I realize that what I'm dealing with here is the product of two functions, x cubed and e to the x. And so that would suggest, hopefully rather quickly, that we need to differentiate using the product rule. So remember, the product rule is the derivative of the first factor times the second factor plus the derivative of the second factor times the first factor. Okay, so our first factor is x cubed, and so the derivative of x cubed, as we all know, is 3x squared. And then we need to multiply that by the second factor, e to the x. And then we'll add to that the derivative of the second factor, which is e to the x. We all know derivative of e to the x is itself, times the first factor, x cubed. Now again, we want to know when this is positive, and in general, if we're not dealing with a linear expression, that we need to know when it's positive or negative. It becomes a little bit more challenging in solving when it actually is positive or negative directly through an inequality. So it's easier to find the roots of the equation first, find out when the equation equals 0, and then we'll test to see where the values of the derivative are positive and negative. And I'll talk a little bit more about that in a moment. First of all, let's note that we have at least an e to the x in each term here. I know there's also an x squared in each term, but I want to highlight something here in this solution. So I'm just going to factor out the e to the x and leave the other terms together as one. So I have a 3x squared plus x cubed, like this. So again, the next thing we're going to do is we're going to solve when f prime of x is equal to 0. And f prime of x is equal to 0 when this expression that I just wrote is equal to 0, and that expression is e to the x times 3x squared plus x cubed. Now, at this point here in solving this, hopefully one of the first things that comes to mind is the zero product property. I'm multiplying two things together and the result is 0. And the only way that can happen is if one or more of the factors themselves happen to be 0 at particular values of x. And with that in mind, the first factor here, e to the x, we should know something about e to the x. E to the x does not equal 0. So there are no solutions to the equation e to the x equals 0. So I'm actually just going to write it like this. E to the x does not equal 0. So we won't have to worry about that solving anything from there. I'll have to get our solutions from the other term, 3x squared plus x cubed equals 0. Now we know that, I don't know if we know this, but hopefully we know that this is going to equal 0. It's not guaranteed that either factor has to equal 0. It might not be true that the whole expression equals 0 at all, but in this case it will. Factoring out an x squared from each term here, and I'm going to try and squeeze this all on this one page, we'll get a x squared times 3 plus x equals 0, of course. And one more application of the zero product property, and I'm just going to write down the solution here because I think we all can probably see it at this point of our mathematical education. X squared is going to be 0 when x equals 0, and x is going to 3 plus x will equal 0 when x equals -3. So we have two solutions to the equation f prime of x equals 0. But remember, we're trying to figure out where f prime is in fact positive, not just equal to 0. And so, let me get a new page here, and we'll work from there. Alright, so we're dealing with the original function f of x equals, what was it, x cubed times e to the x. And I'm bringing that original function up for a moment here because we have to think about the domain of this function here in order to be complete in our analysis. Okay, so just so we note, the domain of f is all real numbers. Hopefully you can see that. The domain of the cubic is all real numbers, the domain of e to the x is all real numbers, the product will accept all real numbers. And so the domain is all real numbers. And the reason why this is important is because if we go back to the first page for a moment here, we had two values of x for which the derivative is equal to 0. And so I need to divide the domain of f up into intervals based off of those values. And since my domain is all real numbers, I'm going to divide the real line up, or all real numbers up by, whoa, I don't know what I did there, excuse me. Back to the right tool. So the real numbers, of course, start out with negative infinity. We had a solution of to the f prime equals 0 when x was -3. So I'm going to put them in order here. I'm going to divide the interval up in order. So negative infinity to -3, because -3 comes before 0. That's going to be one interval. Then I'm going to look at the interval from -3 to the next root, which was 0. And then I'm going to look from 0 and the rest of the interval. Now, if there was more than two solutions, I should say, then I would have another division over here. Say positive 4 happened to be a solution, which of course it wasn't, but then I'd go from 0 to 4 and then make another interval from 4 to infinity. So I just keep breaking up my domain here, all real numbers, by the roots that I found for f prime. Now, we know by our algebraic work from before that f prime only equals 0 at -3 and 0. And so on all of these intervals that we have here, f prime has to be either positive or negative, and only one or the other on that interval. Because, by the intermediate value theorem, if f prime happened to be positive and negative on this interval, then f prime would have to be 0 on this interval, provided f prime is continuous, and knowing the properties of exponentials and polynomials, it is going to be continuous. So there's no way that there's going to be any other zeros in any of these intervals if I've done my work correctly. That's it. So f prime on each of these intervals has to have the same value, either always positive, same sign value, always positive or always negative. So what I'm going to do is I'm going to choose a value in each of these intervals. We'll start with -4 for this one. Choose easy values. Any value works. -1 works over here in this one, and then x equals +1 in this one. Now what I'm going to do is I'm going to test these values in f prime. I guess I should go back and write down what f prime was that we found, at least in factor form. F prime of x was, let's see, it was e to the x. I can recall here, and I think, I'm going to go back and look just to make sure. It was e to the x times 3x squared plus x cubed. Find the cursor, 3x squared a little slowly there. Alright, so now all I need to do is I need to compute, or at least figure out the sign, positive or negative sign, of each of these, of the derivative at each of these values. So f prime of -4, let's go back up here and take a look at f prime. E to the x. We know e to the x is always greater than 0 for all values of x. That's just the nature of that exponential functions. So this is positive, no matter what x is. Now if I plug in -4, what do I get here? Alright, well, let's see. -4 squared is going to be Positive 16 times 3 is 48. And then negative 4 cubed is negative 64. I don't need to actually compute the number. We had 48 minus 64. We know that's negative. And a positive times a negative is going to be negative. So this is less than 0. Then we do the same thing for the other values. F prime of negative 1. Again, e to the x. I can really just ignore this one here because this is always going to be positive, and positive times anything keeps that same sign. And so I'm just going to worry about what's happening over here. If I plug in a negative 1, it becomes a positive 1 here, so this becomes a positive 3 and a minus 1, which is a positive value. And then I go take a look similarly at f prime of 1. And again, if I plug in 1 here, that's positive 3. Plug in 1, that's a positive 1, so their sum is going to be positive. And times that other positive number over there, again, another positive value. One more time for emphasis. I know, because I've found all the roots of f prime, that f prime is not going to be 0 any other place. So in this interval, however f prime is, positive or negative, it's like that on the entire interval. So here, at f prime of negative 4 being negative, tells me that every value in this interval, at every value in this interval, f prime is negative. Similarly, since f prime of negative 1 is positive, at every value between negative 3 and 0, f prime will be positive. One more time, since f prime of 1 is positive, for every value of x in the interval from 0 to infinity, f prime will be positive. Now, we've really answered the question now. Let's go ahead and just summarize the results. At least we've done the mathematics. We haven't actually stated the answer to the question. Okay. So, we already stated way back up in the beginning of our solution over here that we needed f prime to be positive for f to be increasing. So I don't necessarily have to restate that down here. Okay, I've already made that statement. So I can just say here now something like this. Since f prime is greater than 0 on negative 3, 0, union with 0 to infinity, they're not, excuse me on that one, that should be just f prime. F is increasing, now this is going to be a little different, f is increasing on the interval from negative 3 to infinity. Now some of you are probably thinking, wait a second here, hold on. F prime of 0 was 0. Why are we saying it's increasing at that point? There's a little technical detail in the definition of increasing function that allows the derivative to be 0, not constantly, just at a particular point, and still say that the function is increasing on that point. Okay? Because if I take some value to the left of 0, 0 is going to have a greater value, and I take some value to the right of 0, f of that number is going to be greater than 0, so around 0 the function is increasing, although it does level out at 0 for just a moment. Also remember for the AP exam, depending on the definitions of textbooks, we could include a closed interval here or an open interval. Doesn't matter, the AP exam is not going to grade it, so you can leave it just like the way I put it here, and the answer will be correct. Please watch this more than once if you need to get the solution down and understand each part, and then perhaps go try a different question on your own. 52, although they didn't ask about being increasing or decreasing, you can go apply the same technique and see where that function in 52 is increasing or decreasing.